Good morning, BPKC members. This is Jessica Saravia. I'm the past chair, and this morning I am going to attempt to answer an ARE study question from my coworker, Marissa Wilkins, who recently passed her exams. This question is about condensation, so we'll jump right in. The question is, an architect is designing a building in a cold climate and wants to eliminate condensation on the interior surface of the building's exterior walls. Which of the following will help eliminate condensation? Check the three that apply. Increasing the wall insulation, eliminating the wall insulation, raising the interior relative humidity, lowering the interior relative humidity, raising the surface temperature of the affected area, or lowering the surface temperature of the affected area. What we're talking about here is the phenomenon of warm, humid air from the inside of your building in a cold climate will be seeking the cold. High energy seeks low energy, heat seeks cold. So in the winter, this hot, humid air is going to be trying to find its way outside. And as it hits the face of your exterior wall, if that surface is cold, colder than the dew point of your interior air, you could get condensation, meaning the humidity in your air to turn into liquid water. This is what we're trying to avoid, and let's see how best we do this. So the first solution would be to increase your wall insulation. As any of us who live up north know, you don't wear a light jacket in the winter. You bundle up, you have as many layers as possible. You stuff your stud cavity full of insulation. You have exterior insulation. You get as much R value in that exterior wall as you can so that the cold, dry air outside doesn't allow the cold to radiate its way through your wall and hit the interior of that dry wall with the cold. It gets stopped somewhere in the middle by your insulation, and the dew point is within your wall system and doesn't make it to the interior. So the interior surface of your wall is warm above the dew point, and when your warm, humid air hits it, no problems. The second option might be to lower the interior relative humidity of your space. If your interior air is warm, it will hold more moisture than cold air. So I think it's sort of intuitive, but it bears noting that, it's like in the winter, your skin dries out, right? Everything dries out. Colder air doesn't hold as much moisture as warm air. And so your interior air in the winter is going to be more humid than your exterior air. But that being said, you could reduce the amount of humidity, dehumidify that interior air a bit so that there is less moisture in that air. And when it hits the exterior wall, maybe there's less of a chance of it creating condensation. So when John Wick is roaming through the desert, he has a bottle of water. Maybe that water is cold, but the desert air is so dry that there's no humidity for it to create condensation on the exterior surface of the bottle because it's just dry. There's nothing there. The third option would be to raise the surface temperature of the area, of the actual wall surface itself. So this is also kind of intuitive. I think if you look around, you'll see frequently diffusers along large expanses of glass to heat and cool that area, or baseboard heaters, radiators in older buildings, because glass has such poor thermal performance, and you're trying to overcome that heat loss and that cold that you're getting on the inside face of your glass, not the inside face of your building. You don't want condensation there in the same way that you don't want it on the inside face of your exterior wall in other places. So you could heat the face of the wall on the inside to try to overcome some of that condensation possibility. The thing that makes me nervous about this is that with glass, typically you have an insulated glazing unit, so the air between the two panes of glass is what gives you your thermal break. But here in your wall, we don't know what's in that assembly, and you might have the backside of your drywall could be cold still, or another part of your sheathing could be cold, and the heat could still be hitting another area within that wall assembly somewhere and causing condensation, and you just don't see it. So that makes me a little bit nervous, but in principle, it still works. And this is a good example. This is the Denver Art Museum, the old building by Gio Ponti, which is beautiful. This is the curved structural glass, big expanses of glass, but you can see the diffusers along the ceiling to help alleviate the heating and cooling along there. And it looks like we answered the question, but I just wanted to note that the corollaries for all these answers are also true. So if you are designing a building with a space on the inside of the exterior wall that has, let's say, a high relative humidity for whatever reason, a gym locker room that has showers and saunas and steam rooms, or obviously a pool or something like that, you have to take care to really insulate the heck out of your exterior wall then, because you have a much higher chance of getting condensation on that wall because there's so much humidity in your air, right? Just by a function of what the space is being used for. And then also, this is an example from my own house because we have a really old house, and our front entryway is on a crawl space that's insulated, but not very well. And in the really cold parts of winter, we have these giant drapes that we use to cut off that area of the house from the rest of the house so that it doesn't bring all of the house down a few degrees and make it much colder. But that whole area then is colder than the rest of the house. And on the right, you can kind of see, hopefully you can see, there's condensation on the inside of those windows. Sometimes we get it on the inside of the walls too. But we're lowering the surface temperature of the inside of those walls in order to, save the rest of the house. But in this case, that's bringing it below the dew point of the rest of the indoor air. And so when the indoor air, makes its way through and around those curtains, we get condensation on those windows. So if you are working on a renovation where you do have like poorly insulated foundations or slabs, or you're not able to get ductwork close enough to the exterior wall, you don't have a lot of supply air, you should think seriously about providing baseboard heat, providing electric heat, doing radiant floors, or providing some other heat source in order to raise the surface temperature of those spaces or of those surfaces so that you can avoid condensation in those cases, so that you don't end up with something like this. Even though we know this is self-imposed, it's just something to keep in mind with older buildings. And like I said, if you have any areas that are tricky to get hot air or move air around. So yes, both and. So that was it for today on condensation, but we will continue to follow up. And if anybody has any other ARE study questions they want us to take a deep dive in, let us know. Post them in our BPKC discussion thread on the Community Hub, and we'll go for it. I have a couple other ones in the wings that we'll keep working our way through in the coming weeks, but we'll talk again soon. Thanks, everybody. Have a great weekend.